Pedro, are you okay?
Yes, sir.
So it's another example of uniform velocity motion. Okay, where the definition says that when a body covers equal distances within equal time interval, such motion is what we describe as uniform velocity motion. But here, because there is a decrease in the distance covered by the body, the slope which is equal to its value, the slope which is equal to its what?
Sir, please come again.
I said the slope which is equal to its what? The slope of this is equal to the body's what?
Um,
Maybe hurry up. The slope is equal to the body's what? Velocity. Velocity, baby. It's a negative
I was
one.
going to say what?
But don't waste time, please. If you have to give a response, be quick about it. Okay. So we have this is how we can have a negative velocity when the body's distance decreases or displacement decreases within equal intervals with time. Is that okay? Then we have, can I join this? We have
Yes, sir.
a non-uniform velocity motion. And let's also look at what goes into a non-uniform velocity motion. A non-uniform data. So distance as against time so 0, 1, 2, 3. Okay, let's use only 3.
After distance and displacement or distance and
Yes, you are still on displacement. So 2, 5, 10, 12, 15. What is happening here? What is happening to the distance covered by the body? What is happening to the distance covered by the body? Is it an increase or a decrease? Good. It's an increasing distance with time, equal time interval. But when you cross such a motion, the displacement against time. This time you will not get a straight line because the intervals do not, the change in displacement doesn't occur within equal intervals.
so even if change in this does not equal interval, but the change the rate at which time changes occurs in equal interval. So it will be a non-uniform
Yes,
and vice versa.
yes. And it's our non-uniform, I will explain. Okay. So when you plot such a graph on a scaled graph, okay, you have a curve like this. Because the intervals of the displacement doesn't occur within equal. So it won't give you a straight line. It will give you a curve. Okay, it will give you a curve 0, 1, 2, 3, 4. Okay, now because this is not a straight line, you can only find the slope. When you find the slope, you will have an equal value, a uniform value as we had in that case.
But when we do any function, we plotted the point before drawing a line. And then it looks like that.
And because you say this is not a grade line, so when I do, you won't see it. You won't see the curve. You see, these values of displacement are measured. I'm just guessing. So I can even, okay, 1, 2, 3, 4, 5, 6. Okay, let's assume this is 5. Okay, or 2, 6, 8, 10, 12, 14. When I plot, you won't see the curve because it's not grade line. Okay, so at the time of 0 will be here. At the time of 1, the distance is 5. Look at this is 2, 6. Okay, I'm sorry, even 4, 6, 8. Okay, meaning where will be 5? This is 2. Where 5 will be somewhere here. When I join, let's do it.
Yeah, so you can do it on a graph.
Yes, and you will get a curvy pattern. Oh, time, we have a lot to do. So I just want to give you, okay. So if you are, Mami, are you there? So 0,
Yes, please.
okay, 0. At time t is equal to 0, the displacement here is 2. It can be 2 when the motion hasn't started. So this is 0. So if I say 0, 5, 10, all right. So 0. At the time t is equal to 1, displacement is 5. 5 will be somewhere here. So when you can try when we finish, okay, let me reduce this to 2 so that the curve is not so steep or sharp. So this is 2. Okay, the next is 5, 10, 10, 12. So at t is equal to 2, the distance covered is 5. T is equal to 3, distance covered 10. T is equal to 4, distance covered 12. That's what I'm saying. Because it's not a properly measured grade line. You still see it as a straight line. Is that okay? But on a grade line, if the intervals are not uniform, you see a curve. It will be a curve. All right. Pedro, are you okay? Namiaba?
Yes, yes.
Good. Now, because this is not a straight line, you can't get a uniform slope. Part of it, slope is how the thing is inclined. Okay. Over here, we have some, so over here it's increasing. So you don't have a uniform tilt or incline something. Okay. So you can't find a uniform slope for everything. You can only consider slope at a certain time. Maybe the time between 1 and 2 or 0 and 1. You draw a straight line to it and find the slope between these two time intervals. So slope here become change in the vertical between the chosen time interval, okay, and then the change in the horizontal.
I don't get it. Well, where you do it,
This I am just drawing a tangent, okay, to this. But you see, because these are not gray line, you can't even read the vertical minimum and then maximum and all that. That's okay. Now I can also choose this point, maybe the time 3, the slope between the time 3 seconds and 2 seconds. And to do that, I draw a tangent. Okay, meaning this is it. Between this time 3 and 2. The vertical, changing vertical, changing horizontal. And then, okay,
because you get to just for the time.
within that chosen time interval, okay, if I choose this time, maybe 3 and 4, okay, there is it. I draw a line, a tangent, okay, changing this to find that slope. So you can only determine slope, which is also equal to velocity within a certain instant, but not for the general situation. So if you have a non-uniform velocity motion, the slope of a non-uniform velocity motion will always give you what we call instantaneous velocity. It's equal to instantaneous velocity. Instant is time, velocity within a given time interval. But you can't have it for throughout the motion.
So meaning that if the time like
The time interval always it can be uniform or non-uniform.
so
But
if it is not and then the other one is uniform, you use that one like
which one?
the
The distance is always non-uniform, but the time can be both, either uniform or non-uniform.
And
Okay.
if the time is not uniform, will it still give you a curve
Yes,
and to still mean
yes. You can only determine velocity within particular time interval or instant. So instantaneous velocity is simply velocity within a given time. Okay, and it pertains to when the motion is not uniform or when the motion is non-uniform. In a non-uniform motion, the displacement of the body, okay, does not occur within equal intervals, but the time can be within equal intervals. And when you draw such a graph, each slope, of course, the slope of a displacement time graph is equal to the velocity of the body, but you can only find the speed of the body within a given time interval. Okay, find the velocity of the body within time interval from 3 to 4. Then you find, oh, within this given time interval, it is this. Oh, okay. Find the velocity of the body within a given time interval 2 to 3. Oh, okay. Is that okay? And so that will give you the velocity within that given period. Hence, instantaneous velocity. Now I put it to you. I ask, Mami, how about you find? And Bedu.
Yes, sir.
I told my boy I send a meter because the fee they are buying. I put it to you. Let's look at, assuming you want to find the velocity within the time interval 2 and 3. And then the velocity within the time interval 3 and 2. Which one do you think will be greater? the velocity within the time interval 1 second and 2 seconds, and then 2 seconds and 3 seconds. Which one do you think will be greater? Three and 2. You think that this will be greater than this? Why? Why do you think so?
Because
because the 3 and 2 is becoming
And you can
because at the time 2 and 3 seconds, yeah, looks inclined more than 2 and
exactly. And because the displacement 2 is an increasing one, okay, the displacement is increasing. So we realize that for an increasing value of displacement, even though Mami Araba and Betty pay with listen to it with right attention, because the displacement of the body is an increasing one, even though it's not within equal intervals. Okay, the velocity as the time increases will be greater than as the time decreases. So that is why the velocity within the time interval 3 to 2 will be greater than the velocity within the time interval 1 to 2. And certainly the velocity within the time interval 4 to 3 will be greater than all the. Mami Alba and Bedo, are you okay?
Yes, sir.
Hello. So as you listen, you put some information down, okay? And because of this, because the velocity within each time interval is an increasing one, we also say that in a non-uniform velocity motion, in a non-uniform velocity motion where the body's displacement increases, though not within equal intervals, the body accelerates.
that is the
No, we'll come to it. With the acceleration. Okay, the body accelerates. Why does the body accelerate? Because the velocity as the motion continues or goes on is what? Increasing. And when you have an increasing velocity with time, what does it amount to? Acceleration. So over here, we can deduce two things. The velocity, the instantaneous velocity, and we can also deduce that the body accelerates. The body accelerates because as time increases, the velocity within any chosen given time would increase as the body goes on and on. Is that okay? Is that okay? And these are the technicalities in this thing. Bedu and Mami Araba, are you there?
Yes, sir.
Mami Araba, I can't hear from you. Have you gone to sleep? As you listen, you put some information down, as I said. Okay. Now, when it happens that, let me add the other one so we put. When it happens that, yes, the velocity, when we change, the distance covered decreases. within an, okay, we also have a non-uniform velocity motion. Here, the instantaneous velocity will be a positive one, right? The instantaneous velocity will be a positive one. When the distance decreases, the instantaneous velocity will be a what? A negative one. And we can say that the body would what? Decelerate. When is the other way around? Not so difficult, but you got to understand. You got to understand and apply.
Can you read that?
In a non-uniform velocity motion, where the body's displacement increases, though not within equal intervals, the body accelerates. If it's a situation of where the body's displacement decreases, though not within equal interval, the body would what? The body will what? Bedu, did you get that? Mami Abba, did you get that?
Yes, sir.
Really? So not so, but you need to understand. You need to understand, and every question related to it, so you just so you can only under this you can only get the velocity within a particular instant or period, hence instantaneous velocity. So instantaneous velocity, okay, of a body is when the motion is a non-uniform, okay, it's a non-uniform, and you can only determine within the velocity of the body within a given time, period, or instant under a displacement time. All right. So when you go to school, you make to know with the what is it. Baby, okay. You go and make noise
Yes,
with
sir.
it. All right. Let me test your understanding on something before we move on to. I want you to think through something and tell me if you have a displacement time graph and the motion is like this, what does it mean? Mamiara, I can't hear from you. You don't talk. What is your secret? Or she's gone.
Mr. Edria,
Yeah, talk. Let me hear from you. If the motion is like this under displacement time graph, what does it mean? Mamiara, give us your opinion first. before you go and sleep. Okay.
Mr. Dia,
Mami Araba.
please. What I understand is the motion is constant.
What do you mean? What do you mean by the motion is constant? So, Mami Araba, why do you think the motion is constant? Okay. Kenneth is also saying that the body is at rest. Let us understand why that observation.
I think the body is right because for the lot for you to get a rest, it is a change in displacement and a change in time. But the graph, there isn't any change in displacement, but then there's a change in time. Meaning the body,
There is no change, or there is, but there's no change in this place.
but then the time is still moving. But then for the body to move, it has to move from one distance or one displacement to another displacement. But between the body,
Yes. Okay.
Immaculate, what do you also think?
Okay.
You think it's a what? Why?
Yeah, as you said, you can
Mhm.
see that from the point is the line is going with you unless it's passing through the point to run down the X and point. But then from the way it's only touching one point of the situation, I mean it only has one there, but it's moving along the line and along. Mr. Dia.
Hello, Mami Araba.
So even if you're finding fault with Mr. Dia. Why one
Okay. Mami Araba, I'm here.
Please, please, I was having problem with my laptop. So after, can I have the video of the lesson?
That's why I'm recording. As to how I'll send it to you is my dilemma. So how will I get it to you? Because I don't have your number. Or send it through Miss Posa. Medu, so what do you also think? Medu, what do you make of this motion? Okay. So just as Kenneth and then Immaculate said, this body is, this is a graph of a stationary body or the graph of a body at rest. Why is it at rest? Look, at time t is equal to 0. The distance covered by the body is this over here. Let's assume this is X. At time t is equal to 1, the same distance, same distance, same distance, meaning the body is at the same place. So the body is stationary. So a graph of a body at rest. This is a graph of a body at rest or a graph of a stationary body. All right. Now, what you have to note is that when a displacement time graph is given and the slope to the time axis, look at the first one, uniform. The slope to the time axis is constant. If this is theta, theta is constant. If this is 30, this angle is 30, on and on and on, right? If theta is constant, then it's a graph of a constant or uniform velocity. It means the velocity will also be constant or uniform. So when theta is constant, then it's a constant or uniform velocity motion. So here it is the angle the velocity makes with the time axis. Don't forget. So when the angle made with the time axis is constant, then it will, the motion would have a constant or uniform velocity. If the angle theta made with the time axis, if the graph makes an angle of 0 degrees, angle of 0 or theta is equal to 0 degrees with the time axis. Then the velocity is 0. The body is stationary. Then v is 0. Here, this line, whose gradient is 0, is parallel to the time axis, isn't it? And what is the angle between parallel lines? Parallel lines have an angle of what? 0 between them. They do, are you there?
Yes, sir.
So parallel lines have an angle of 0 between them. And so when the angle between the time axis and then the graph or the line is 0, then the velocity is 0. If a body has a 0 velocity, what does it mean? It's stationary or at rest. Okay. Another point. If the angle made with the time axis, theta, is an increasing one, look at this thing. Look at this graph. With the time axis. As time goes on, what is happening to theta? So the velocity would increase. The velocity along the line would increase. Hence, the body does what? Accelerate. Okay. We are so what? Yeah, we have some motion. Linear motion. Then, if you have this situation, look at what is happening. As time goes on, what is happening to the angle between this, the time axis and the curve? Decreasing. So the velocity would what? Be decreasing, a deceleration. So, what's it? As time goes on. No, did you say? Oh, okay. I'm coming. A different and let's look at it this way. This is also an increasing situation with the time axis, but in the opposite direction. That's why it's a deceleration. Okay, time. So 1, 2, Okay, same thing. Same thing here. Okay, at 0, this is the whole angle it makes with at 1, at 2, at 3. Okay, it's also an increasing situation, but in the opposite direction. Hence, a negative, same value as this, but it's a deceleration because it's against the direction, it's against this one. Yes, it's a negative acceleration and it's a deceleration or retardation. Vedo, are you okay? So those are the tricks
Yes, sir.
involved. I have a printed out notes on this. Let's move on to velocity time graph. If you finish, come and tell me, so why. So velocity time graph. Which we shorten as V-T graph. So here it's about plotting the velocity of a body, okay, to the time, okay, to the time taken by the body to make that velocity.
And so when we were talking, learning about the